So have you ever really thought about how your exam papers get marked? Like, what are the examiners actually looking for? Well, today, we're going to crack the code on GCSE Maths question 18. We'll be using the official mark scheme to go beyond just finding the right answer. I'm going to show you how to lock in every single mark available.
All right, let's jump right in. This document you see here, this is the official mark scheme. Now, don't just think of it as a simple answer key. No, it's more like the examiner's secret roadmap. It lays out exactly what gets you points, from the way you set up the problem to that final number. And yeah, we are absolutely going to use this to our advantage.
So here's our game plan. First, we'll tackle the frog problem itself. What's it all about? Then, we'll decode the lingo the examiners use. After that, we'll walk through solving Part A, which is the calculation, and then Part B, the assumptions. And to finish, we'll wrap it all up with the most important takeaways for your exam day.
Okay, let's start with the problem itself, the frog capture-recapture. This is a real classic. The whole challenge here is to figure out the total number of frogs in a lake, but you can only use 2 small samples. So it's not just about crunching numbers, you know? It's a great example of how we can use maths to model what's happening in the real world.
Right. Hold on. Before we even think about touching a calculator, we've got to learn to speak the examiner's language. Seriously, understanding how you get the marks is just as important as getting the right answer. So let's break down what these little letters, P, A, and C, actually mean.
Okay, first up we have the P mark. P is for process, and this one is so important. You get this mark just for showing you have the right method. It's basically the examiner giving you a thumbs up and saying, yep, you know how to tackle this. It rewards your thinking, even if you make a tiny slip up in your arithmetic later.
Next is the A mark, and you've probably guessed it, A is for accuracy. This is for hitting that correct final answer. But, and this is a big but, it's only awarded after you've shown a correct process. You can't just guess the right number and get the points. You have to earn that P mark first to even be in the running for the A mark. And last but not least, the C mark. This one stands for communication. You get this for explaining your reasoning really clearly, with a statement that's spot on and can't be misinterpreted. We're going to see this one pop up in Part B of the question.
And all of this leads to probably the single most important rule, and this comes straight from the official guidance. A correct answer with no supportive working gets 0 marks. Just let that sink in for a second. The answer by itself is worth absolutely nothing. Your working, your method, that is everything.
Okay, so now that we've decoded the rules of the game, let's get into the calculation for Part A. We're going to see exactly how to build up our solution and stack those P and A marks.
So, to get that first process mark, the P1, what's really cool is that the mark scheme shows there's more than one right way to start. You could find the ratio by doing 55 divided by 11. Or you could use a fraction like 11 over 55. Or you could even set up a ratio of tagged frogs to untagged ones. Any of those starting points get you that first mark. You're on the scoreboard.
All right, once you've got your starting point, you use it to get the second process mark. This one's for setting up the full calculation. Basically, the logic is that the fraction of tagged frogs in your second sample should be about the same as the fraction of tagged frogs in the whole lake. That gives you the proportion. 11 out of 55 is equal to 40 out of, well, let's call the total n. To find n, you just rearrange it, which leads you to the full process. 55 times 40, and then divide all that by 11.
And when you run those numbers, you land on the final answer, 200. Boom. That's what gets you the A1, the accuracy mark. But remember why you got it. You only get that mark because you showed all that correct working first.
Okay, calculation done. Now let's move on to Part B. This is where maths gets real. We have to think about the assumptions we made. I mean, for our estimate of 200 frogs to be any good, what had to be true about the real-life situation in that lake?
To snag that communication mark, the C1, you just need to state one of these valid assumptions. And the mark scheme is actually pretty helpful here. It gives a whole list of good ones. For example, you could say that no frogs entered or left the lake, or that none of the tags fell off. Another great one is that the second sample was totally random, or maybe that the tagged frogs had enough time to mix back in with everyone else. You could even say that no frogs were born or died in between. Just one of those, written clearly, gets you the mark.
But you've got to be specific. It's super important. Look at the difference here. Saying no new frogs have arrived. That's precise. It directly relates to the thing you're trying to measure. But saying something vague like, this is the same lake, well, of course it is. That doesn't get you any marks because it doesn't explain a weakness in the method. Same thing with, there are lots of frogs. Be specific about the conditions the math depends on.
All right, we've gone through question 18 from top to bottom. So let's wrap this up and boil it all down to the key things you need to remember for your exam.
Just remember these 4 things. 1. Always show your method. That's how you get those P marks. 2. An answer with no working is worth 0. Zilch. Nada. 3. Think about the real-world story behind the numbers to get those C marks for your assumptions. And 4. Don't forget, there can be multiple right ways to start a problem. So if your method is logical, be confident with it.
And you know, this whole capture-recapture thing is way more powerful than it looks. It's a real technique used by scientists to estimate animal populations, and even by programmers to estimate the number of bugs in their software. It's just a fantastic example of how a pretty simple ratio can give us a window into a really complex world. So I'll leave you with a question. What other big, complicated problems do you think you could get a handle on using a simple tool like this?